In this video, we are going to look at empirical and molecular formulas. To start with, we need to define both. First, a molecular formula is the actual number of atoms in a compound. For example, glucose is made up of 6 carbons, 12 hydrogens, and 6 oxygens to give us a formula of C6H12O6. An empirical formula, on the other hand, is the simplest formula, which means it's the lowest whole number ratios of atoms. If we take a look at glucose, we can divide all of our numbers by 6 in order to give us a lower ratio of CH2O. And this would be the empirical formula because it is the lowest whole number ratio of the atoms within this molecule. We're going to look at an example then. Given that a compound contains 12.7% carbon, 2.1% hydrogen, and 85.2% bromine, calculate its empirical or simplest formula. There are 3 steps that you always need to follow when finding an empirical formula. The first is that since we're given percentages, we're going to make the assumption that we have 100 grams of the substance. This is going to give us easy numbers to work with. We're then going to do a mole calculation using the mass divided by the molar mass to calculate the moles of each element. Finally, we're going to do a ratio calculation where we're going to find the smallest number of moles in the previous step and divide each of the other values by this number to determine the ratio between the atoms in the formula. And then that will give us our empirical formula. It's always nice to set up a table for these types of problems because it helps you to organize your calculations. So starting with step 1, we're assuming we have 100 grams. So that means you would have 12.7 grams of carbon, 2.1 grams of hydrogen, and 85.2 grams of bromine. And that's because the problem told us we had 12.7%, 2.1%, and 85.2%. So that just translates then to grams. We're next going to calculate the number of moles using our mass over our molar mass. So for carbon, for example, you got 12.7 grams, and every mole of carbon is 12.01 grams per mole. So that gives us 1.05745 moles. A good idea to keep about 4 non-zero decimal places so you can avoid rounding off errors later on. So let's continue. Hydrogen, 2.1 grams, divided by the molar mass of hydrogen, which is 1.01 grams per mole. That gives us 2.07920, number keeps going on, moles. Finally, the last one, we got 85.2 grams of bromine. Each bromine is 79.90 grams per mole. So that gives us 1.06633 moles of bromine. To find our ratio, the above is step 2. To find our ratio, which is step 3, what you want to do is take a look at each of your mole values and figure out which one is the lowest. So if we take a look at the 3 that we have in this example, carbon has the lowest number of moles. What we're going to do then is divide each value by the number of moles of carbon, so by the 1.05745 moles. So if you take 1.05745 and divide it by itself, you would get 1. If you take 2.07920 and divide it by 1.05745, you get 1.9 6, 6, so on, which is approximately 2. And finally, if we take 1.06633 divided by 1.05745, you get 1.008, which is approximately 1. So what this means is that for every 1 carbon, we have 2 hydrogens and 1 bromine. So our empirical formula would be CH2Br. The ratios are giving you the subscripts in your empirical formula. Now to find a molecular formula, we need to take our calculation one step further. So in this example, it asks us to calculate the molecular formula in the compound in the previous example if the actual molar mass of the compound is 190 grams per mole. So what we want to do is we want to take and find our ratio of our molar masses of our molecular formula versus the molar mass of our empirical formula. What that's going to give us is a multiplication factor. And it's going to tell us how many times we need to multiply our empirical formula by to get our molecular formula. So the problem tells us what our molar mass of our molecular formula is. It's 190 grams per mole. And then we want to calculate the molar mass of our empirical formula, so our CH2Br. If you do that calculation, and you should double check and make sure you get the same numbers, you get 93.93 grams per mole. So if we take 190 divided by 93.93, you get 2.022, so on. So that's about 2. Meaning that our molecular formula is twice our empirical formula. So you're going to multiply each of the subscripts in your empirical formula by 2. That gives you a molecular formula of C2H4Br2.